This video goes over how to find the shortest distance from a point to a line. The first thing that you need to know is that the shortest distance from a point to a line is the perpendicular distance from the point to a line. There are 5 steps. Find the slope of the given line, find the slope of a perpendicular line to the given line, find the equation of the perpendicular line through the given point, find the point of intersection, find the distance from the given point to the point of intersection. So this question really takes stuff from the first unit and stuff from this unit to put it together. So the first example that we're going to do is distance from the origin to a line. And we're going to determine the shortest distance from the origin to the line, y equals 2x minus 10. We're going to find it as an exact solution and then as an approximate solution to the nearest tenth. So the first thing that we're going to do is to find the slope of our given line. So that I can read because my equation is in slope y-intercept form. I'm also going to plot that on the grid beside me here. So I've got my y-intercept here at minus 10. I'm going to go up 2 and over 1 to get to my next point. I'm going to do that a couple more times. And then I'm going to use my ruler to draw a line through those points. And now I can label my line here. So I've got y equals 2x minus 10. Okay, so that's my first step. My second step is now to find the slope of a perpendicular line to the given line. So find a perpendicular slope. So if you remember, that is the negative reciprocal. So my perpendicular slope is going to be the negative and the opposite. So I'm going to flip the equation here. And now I'm going to find the equation of that perpendicular line. Now you might say, well, I know the slope. What is the point that I'm using? So in this case, we're doing the distance from the origin to the line. So the point that we're actually using is going to be 0, 0, which is going to be our x1, y1. So we've got x1, y1. That's going to be our origin. So let's put my ruler on again here. Rotate. Okay, so it looks like it's about 90 there. And then I'm going to draw my perpendicular line here. And really what I'm looking for is the distance from here to here. That is my distance. Okay, so the equation that I'm looking for, let's call this line B, is I'm going to use the point slope form that we did in the last video. So I'm going to start off with y minus y1 equals m times x minus x1. And then I'm going to substitute in my points, which is 0, makes my math nice and easy, which is great. So we're going to get y equals minus 1/2 x, and I can rearrange that to standard form as x plus 2y equals 0. Now you might ask, why are we finding the equation of that line? Well, if you remember, we're looking for the shortest distance. So we're looking for the distance here. I will highlight in yellow. Right here is where we're looking for the distance. Okay. In order to find that distance, we really need this point right here and then this point right here. So the 1 is the origin. That's great. We know that. The other one is going to be the intersection of those two lines. In order to find the intersection, we do need to find the other equation. So we've done that. So now our next step is going to be the point of intersection. Flashback to unit 1 here. So our first equation will be x plus 2y equals 0. And our second equation is y equals 2x minus 10. Now you can use whichever method you'd like here. I'm going to use substitution because my second equation is already rearranged for me. So I'm going to take this part here and I'm going to substitute that in where y is in my first equation. So I've got x plus 2, and then I'm putting in my expression for y, 2x minus 10, and then my right-hand side is equal to 0. Now I have an expression in terms of x that I can solve, and it works out that I get x equals, oh dear, it works out that you should have 20, 20, and then x would give you 4. There we go. Okay. So make sure when you're expanding, don't do what I did. Make sure that you multiply both terms inside the brackets. Okay. So now we've got our x coordinate of the point of intersection, and now we're going to look for our y coordinate. So I would sub x equals 4 into probably my second equation. So y equals 2 times 4 minus 10, which is going to give us minus 2. So therefore, my point of intersection is 4 minus 2. And I can see that my graph is a little bit off, but I can see that point of intersection there at 4 minus 2, and then 0, 0. Now the last thing that I'm going to do is find the distance, which is really what I was asked to do in the first place. I know my first point is 0, 0. I know my second point is my point of intersection, 4 minus 2. And I know my distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. I have x1, y1, and x2, y2. So now I can substitute that into my distance formula. I've got 4 minus 0 squared plus minus 2 minus 0 squared, which is going to give me 16 plus 4, which is going to give me root 20. This is an exact answer, root 20. We can, if you remember our work from radicals, we can actually break this up into root 4, root 5, which would give us 2 root 5, which would be your true exact simplified answer here. We're also asked to give it as a decimal, so then you would evaluate it in your calculator and you would get 4.5 approximately as a decimal. And that would be the distance, the shortest distance from the origin to the given line in the question. We're going to look at one more example where you're going from a point to the line. So our steps are still going to be the same. The first thing that we need to do is find the slope of our given line. Now this one's a little bit trickier here because it's not in y equals mx plus b form right away. So this one looks not too bad. I'm going to rearrange my equation to get y equals minus x plus 5, which is going to tell me that my slope is minus 1. Then I'm just going to plot that on the graph just because I have it here. I'm sloping to the right, so I'm going to go down this way. You don't have to plot the graph, but sometimes it does make it a little bit easier to visualize what is actually happening. So I will put my arrows on, label my line here. Okay, so I found my slope. I've got a visual picture of my line. Now the second part that I'm going to do is find my perpendicular slope. So my perpendicular slope is going to be opposite sign, and then I'm going to flip the number. That just ends up being +1. Third, I'm going to find my equation of the perpendicular line. In order to do that, I have my slope is 1. I also have the point that's given to me in the question as -1, 3. This is my x1, y1. So I'm going to start with my point slope form. Y minus y1 equals m times x minus x1. And then I'm going to substitute in what I know. 1 x minus 1. Expanding and simplifying, and I'm going to put it into standard form just because I know I have to find the point of intersection afterwards. I would get x minus y plus 4 equals 0. This is going to be my second line. I'm also going to plot that on here. So my point is -1, 1, 2, 3. That's my point. And I'm going to look for my perpendicular distance. I know the slope of that line is 1. So it goes through here. From my picture, it doesn't look like they're going to meet at a nice number, which is okay. I'll rotate this way. Okay. So now I've got my perpendicular line, x minus y plus 4 equals 0. So if you remember from the first example, the next thing that I'm going to do is I'm going to find the point of intersection. So why do I need the point of intersection? The part that I'm trying to find is the distance right here that I've highlighted in yellow. In order to do that, I need to know the two endpoints of that line segment. One of them is the point that's given. The second one is the point that's given in the question. Or the second one is the point of intersection, and the other one is the point given in the question. So the two equations that I have are x plus y minus 5 equals 0, given. And this is the one that I found of the perpendicular line. X minus y plus 4 equals 0. Here, I'm going to use elimination, and I'm just going to add those two equations together. That's going to give me 2x, 0y, minus 1 equals 0, which is going to tell me that x equals 1/2. Now I'm going to substitute my value for x into, let's do equation 2. So I've got 1/2 minus y plus 4 equals 0. So that means that I have y equals 1/2 plus 8/2, which is going to give me 9/2. So I have my point of intersection, which is 1/2, 9/2. And now the last thing that I have to do is find the distance. My 2 points that I have that I'm using are -1, 3, so given in the question, and then the point that I found, 1/2 and 9/2. I also know my distance formula. x2 minus x1 squared plus y2 minus y1 squared. And then I can substitute in what I know. So 9/2 plus, minus 3. Those are my y values. I'll match what I have in the equation. So I'm going to have x2 minus x1 all squared plus y2 minus y1 all squared. Here I'm going to do some work with fractions, so I've got 1/2 plus 2/2 all squared, 9/2 minus 6/2 all squared. So this first one is going to give me 3/2 all squared, which is going to end up being 9/4. You need to square the top and the bottom. And here I've got 3/4 squared again, which is also 9/4. So that means that my exact answer is going to be root 18/4, which I can actually reduce, well, in a couple different ways, but I can reduce this as root 9/2. And then I can even simplify a little bit further to be 3/√2, which as a decimal is going to be approximately 2.1. Two examples on how to find the distance from a point to a line.